Okay, when you finished your last test, you should have picked up a periodic table and colored it as directed. You have your 1 plus, or the red, or reds for me, whatever you have. You have your 2 plus. These I said were 3 plus. Let's see if I can get this a little thinner. Okay, here you have your 4 plus or minus, then your 3 minus, your 2 minus, your 1 minus. This was a 1 plus. Hydrogen, depending on what it is with, it could be a 1 plus or minus. And then all of your transition metals, your inner transition metals, the metals down here, everything that you colored, what was left over, have multiple charge. And we use Roman numerals to explain that, and when we get into writing formulas in a couple of days, then we'll talk about that a little more. So you should already have this written down. Okay, types of compounds that we're going to be dealing with. You have your covalent compounds, which are 2 nonmetals coming together. And we'll talk about how they're named and everything else. You have acids, anything that starts with a hydrogen in the formula or has acid in the name, those will be your acids. And then you have your ionic compounds. That's where the charges are so important, because you'll have any oppositely charged things coming together. And polyatomic ions, that's what's on the back of your periodic table that we haven't dealt with so far. Okay, we also have 2 types of bonds that we're really going to focus on. What happens is that they want to have your 8 valence electrons. So ionic compounds will lose or gain electrons, and your covalent compounds, your ionic compounds are just like with the what we're talking about. You have your metal, non-metal, and then your covalent compounds are your nonmetals only. So when you have 2 nonmetals coming together, they're just sharing their electrons. So the last part of this, where we're going to compare we also have metallic type of compounds. We're really going to focus more on ionic and covalent, but I want to make sure you know about metallic also. What's going on with your metallic is you have your different metals. So when you have metallic, will be just metals together. And then instead of sharing or exchanging your electrons, they delocalize, meaning they move around, which is why metals compounds can be malleable, meaning you can pound it into a sheet. Ductile is when you can pull it into a long, thin wire. Those are the wires in your house. Lustrous, they're always pretty shiny and colorful. They do conduct electricity, and they have the highest melting point. Your ionic compounds, that's where your positives and your negatives come together. That's oppositely charged ions. Those are called cations, are your positive, and anions are your negatives. So your metal, non-metal, or polyatomic ions involved. They're usually brittle. Think about table salt, dull. When they are electrolytes, that means they've been dissolved in water. And they generally have a higher melting point than your covalent compounds. How your metallic and ionic are the same is they both include metals. Your ionic and covalent both include nonmetals. All of them involve their valence electrons. Those are the electrons that are outside of the noble gas. When we were writing our electron configurations, or noble gas configurations, you said we have all of these, and then we have the extra electrons. Those are the electrons that are involved. Those are called valence electrons. In your covalent compounds, again, they're sharing your electrons. You have 2 nonmetals, or possibly a metalloid with a nonmetal. They're polar and nonpolar compounds, and we'll talk about that more in the springtime when we talk about solids. They generally do not conduct electricity, and they have the lowest melting point.